Ever wondered what stops your music app from playing the exact same song twice in a row on shuffle? Well, the answer is this really simple but super powerful idea that's like hiding in plain sight all across technology. Today, we're doing a deep dive into sets. I know, it sounds like the beginning of a bad joke, right? On one hand, you've got these ancient foundations of logic and reasoning, and on the other, you've got your meticulously crafted workout playlist. I mean, what on earth could possibly connect those two things? Well, the connection is this beautiful, really elegant idea. It's a concept that helps us organize the world, both the abstract world of ideas and the digital one, with some pretty incredible efficiency. And trust me, that is not an exaggeration. As this quote from Geeks for Geeks points out, set theory isn't just some random topic in math class. No, it's basically part of the bedrock that everything else is built on. You could almost think of it as the grammar of mathematics. Okay, so to really get a grip on its power, we gotta start with the absolute basics. What exactly is a set? At its heart, a set is really just a collection of things, but it has one critical, non-negotiable rule. Every single item in that collection has to be unique. No repeats. Zero. Think of it like a guest list for an exclusive party where you just can't invite the same person twice. Simple as that. And what's really cool is how we can describe the exact same set in two totally different ways. Over on the left, you've got roster form. We just, list the members out inside those curly brackets. Easy. But on the right, we have set builder form, where we just state the rule for being in the club. It's like the difference between saying everyone on this list gets in versus everyone who fits this description gets in. Both methods get to the exact same group of unique items. Okay, so that's the theory, but let's be real. The reason this all matters so much is because this abstract idea is an absolute workhorse in our digital lives. So let's see how it actually builds the technology we use every single day. And the applications are just incredibly broad. As the source material from Geeks for Geeks points out, set theory is absolutely crucial everywhere, from the deep logic of computer science and philosophy, all the way to calculating odds and statistics, and even understanding how we structure language and linguistics. It's wild. And you can kind of see the journey here, can't you? We start with that simple, pure math idea, a unique collection. Then computer scientists take that concept and build what's called a set data structure, which is just a fancy way of saying a practical tool in programming that lets us handle data with amazing efficiency. So, what can you actually do with it? Well, a classic use case is data cleaning. Imagine you have a massive spreadsheet with thousands of duplicate entries. One of the absolute fastest ways to get a clean, unique list is to just dump it all into a set. Problem solved. It's also humming away behind the scenes in massive databases. Whenever a system needs to combine information from two different tables, an operation that's called a join, it's often using the principles of set theory to do it super fast and without any errors. And hey, we are right back where we started. The whole reason you don't see the same song listed twice in your library is because the app is almost certainly using a set to manage that list, automatically enforcing that no duplicates allowed rule for you. But, just like any specialized tool, a set isn't the perfect solution for every single job. It comes with a very specific set of strengths and weaknesses. And understanding these trade-offs, well, that's the key to using it effectively. So let's break it down. On the plus side, you get guaranteed uniqueness, the elements are often kept sorted, and you get these incredibly fast checks to see if an item is already in the collection. But the downsides are really important to know. You can't just ask for, say, the fifth item like you can with a simple list, and sometimes they can use up a bit more memory. Now that technical term, log n, it might look intimidating, but the idea behind it is actually pretty simple and, honestly, kind of mind-blowing. Think of it this way. Searching a normal list is like flipping through a book one page at a time. But searching a set is like using the index at the back of the book. Even if the book doubles in size, finding what you need in the index only takes one extra step. It's just an incredible leap in efficiency. So when you get right down to it, here's the deal. The core trade-off is speed versus flexibility. You gain this lightning-fast performance for asking one question, is this item in here? But you lose the ability to ask, what item is at position number 7? And for a whole lot of jobs, that's a trade worth making every single time. All right, let's zoom back out for a second and just really recap why this simple idea of uniqueness is so incredibly powerful. If you only remember a few things from this, make it these 3.
First, the core idea is all about enforcing uniqueness. That's it. Second, in the digital world, this simple idea becomes a powerful tool, a data structure that is built for speed. And third, its impact is just massive, forming a foundation for pretty much countless technologies we rely on. I think this quote from the source material just nails it. It's not just about storing your data. It's about unlocking its potential through elegance and efficiency. It's about doing more and doing it faster just by embracing one simple rule. So I'm going to leave you with a final thought. Now that you know this core principle, a collection with absolutely no duplicates, where else in your daily life, digital or maybe even otherwise, do you see this powerful idea of a set at work? Something to think about. Thanks for watching.